So please, these examples, these are the ones you have to solve for me at home. Solve these ones for me at home. Solve all this for me at home. Solve these ones for me at home. So why am I telling you to solve? So that we can quickly enter into ARGAND diagram. Anglement, or you say arguments. Alright, they say, what is ARGAND diagram? And I tell my student that ARGAND diagram is just like a graphical representation of complex numbers. So it's a graphical representation of complex numbers such that if we know that this is y and x and y axis, we say that the real part is represented on the x-axis, the real part of z, and the imaginary part is represented on the y-axis. Imaginary part on the y-axis. On the y-axis. So we'll call this z, imaginary part, imaginary part. So the y-axis is for imaginary parts, the x-axis is for the real parts. So graphical representation of complex numbers, whereby your real part is on the x-axis and the imaginary part is on the y-axis. Alright, so they say we should plot an ARGAND diagram of z1 equals to 1 plus 2i. So what this thing will mean is, for example, if I have this to be my graphical graph, then let's see, and since everything is 1, it's on the first quadrant. So this is going to be, let's say this is 0 origin, 1, 2, then 1, 2. So what this thing means is that on the x part, pick 1, on the y part, pick 2. This is where they meet. As they are meeting here, that means that there is a line that runs through here. This thing you are seeing here is what we call the modulus, the R, the modulus. So, okay, let's progress. They also say we should plot an ARGAND diagram of minus 2, then plus I. So let's say we have this, Let's say this is our origin, 1, 2, 3. This is minus 1, minus 2. Then this is 1, 2, 3. So I there is descending as 1i. So 1. So this is going to be descending as saying, come to minus 2, pick something. When you pick something, this is where they meet. So you see it. So this is your R. So there you have it. So they also say we should plot an ARGAND diagram of 0 plus 2i. So what it means is that, for example, if I have this to be my 0 mark for both x and y axis, then they say 2i. So let's say this is 1, 2. So if this is 2i, it means that nothing can be drawn out here. So it simply means that, just like this. So it simply means that when they give you 0 and 2i, or 0 on the real part and 2i, it simply means that what they want you to plot for is just to plot out or mark out on the y-axis, the imaginary part axis. So in a situation where they tell you 0, and they tell you, for example, 3 plus 0i, like this one, they said plot 3 plus 0i. So let's say this is 1, 2, 3, 1, 2, 3. So imaginary part is always on the x-axis. Imaginary part, they say 0. So it simply means that they want me to just mark out or plot on the x-axis. So they now said, if z equals to 3 plus 2i, plot ARGAND diagram of z and z conjugates. So let's say I have this to be the ARGAND diagram. I have 1, 2, 3, 4, minus 1, minus 2, minus 3, minus 4, 0, 1, 2, 3, 4, minus 1, minus 2, minus 3, minus 4. So if real part is 3 and this on the x, real part, then they say 2i, so this, so it simply means 2 here in the y part, 3 here. So that means this is the z, and the angle I have here is what we call the argument theta. Then here is the modulus r. So if they tell me to find the conjugate is simply going to be, the conjugate of this is simply going to be in such a way that, since I have, remember, if I have the question first of all 3 plus 2i, the conjugate will be 3 minus 2i. So it simply means I'll get 3 here, 3 here, but instead of getting, because this becomes minus 2, so this is minus 2i, isn't that it? So you see, so this is my z complement, z conjugate, and this one is my z. I see it. So this arrow points to that particular complex number. So z and its complement. Let's say they said minus z. What we do is to say minus z will be the same thing as saying everything here minus, that is, instead of 3 become minus 3, instead of 2 become minus 2i. So it will simply be in such a way that this will be minus 3 minus 2. So this is where they will meet, sorry, mistake, but it's the sentence of minus 2 minus 2. So this will be minus z, assuming they said minus z, or they did not tell us to find minus z. All right, now with that said, let's move to what we call modulus of complex number. Explain modulus. I normally tell my students that if you check in physics, you normally see anytime they talk about absolute value, you see something like this, or they tell you value or magnitude, you see something like this. For example, if they tell you modulus of 2, you see like this, or minus 2, they tell you everything modulus is going to be positive. So if that be the case, I tell my student that modulus means magnitude, it means resultant, it means absolute value, and it is simply gotten the same way you get your vector, your resultant vector, that is r square Pythagoras equals to a square plus b square, or since we are dealing with x and y here, you say that this is going to be x square plus y square. So in this case of complex number, to find your modulus is always going to be what you have on the x side and what you have on the y side. So the real parts and then the imaginary part, and the I does not come in here, all squared. Take their square roots, r equals to. So once you know this, then I said, what is the, okay, they said find the modulus of z minus z and conjugate of z, where z equals to 4 plus 3i. So if z is equals to 4 plus 3i, they are telling us to find the modulus of z. Modulus of z will be equals to, that is r of z will be equals to r square equals to x squared, the real parts 4 square plus the imaginary part 3 square. So by the time you make this subject of the formula, this square will cancel, so that r becomes square root of 4 square, which is 16, plus 9, 3 square, which is 9. So carry 4, put here 20, plus this 5, plus, yes, carry 4, put here 20 plus 5, that is meant 25. So square root of 25. So you see that r will just be equals to 5. That's the modulus. You see sometimes we represent it as small r, or let me represent it as small r, so you don't get confused. Yes, it's not like physics where you use capital letter to represent it. I'm rushing this, I have programming class to catch up with. Now the next thing they say we should find is of minus z, and minus z will be the same thing as saying minus everything on this. So it's going to be, instead of z, it will be minus 4, then minus 3i. So another way to know that minus z is the same thing as saying, since I have z equals to 4 plus 3i, minus z will be the same thing as saying minus, by the time you do it, you see that it's the same thing. So this is going to be, the modulus will simply be minus 4 square minus, sorry, yes, plus minus 3 square. This is going to give you 16 plus 9, which is the same thing as 25, 5. Then they say for the conjugate of z, and z conjugate is the same thing as saying, since this is z is 4 plus 3i, this will be 4 minus 3i. So the r will be the same thing as saying 4 square plus minus 3 square, which is 16 plus 9, I will be equals to 25. I will be equals to 5. So notice that in this case, z is equals to negative z is equals to z conjugate. So this proves that modulus of negative number will always be positive. Alright, now let's move to the next topic, which is arguments of a complex number. If you don't call it argument, you call it anglement. This is just you finding theta. Explain argument of a complex number. Alright, so it's let me do it. So if, for example, I know that from here to here is pi over 2, y here is pi. Are you seeing it? So what it means is that from this end to this particular end is going to be 2 pi. That is the whole circle. That is why we call this 360. This is 90. This is 180. Notice that I ignored these 270. I ignored these 270. I did not call it anything. That is why when we are treating complex number, once we find the particular place that the thing fall into, we don't use 270. Rather, let's say I get something that falls into this quadrant. What I will say is add, since this is 180 and let's say I get 37 and that 37 falls around here, I'll simply say 180 plus 37. 180 plus 37. That will be the arguments that I'm looking for. If it falls here, if it falls around here, I'll simply say whatever I have, 360 minus that thing, I'll get what I have. If it falls here, I'll use it like that. If it falls inside 180, I say 180 minus what I have, I'll use it. So for here, we do 180 minus theta. For here, we just have theta. For here, we do 180 plus theta. Then for here, we do 360 minus theta. And what is theta? Theta is the angle made. Theta is the angle made with our z, our sets, and should I say yes, so the angle made by z, that is the complex number with the ARGAND diagram. So when you get it, whatever it is, you see how to find it as we progress now. Then they say give equation for finding argument of a complex number. So the equation is simply given by always knowing that you're always using the part that makes touch with the horizontal. So that means that, why am I using the part that makes a touch with the horizontal? It's only when you make the angle touch the horizontal that you will know that moving towards the angle will always be you using cos, and towards this horizontal is x-axis, while towards the vertical is y-axis. X-axis and y-axis. So if I know that, that means that when I'm moving away, I use sine. Away from the angle, use sine. Towards the angle, use cos. So which means that this is going to be the same thing as saying for the argument, I'll have r sine theta to be equals to y, and then for x it will be r cos theta. It will always be that way. And we know that whenever we have something of tan theta is always y over x. So which means that to find theta is going to be theta equals to tan inverse of y over x. So if we are presenting this now in the next topic that we are treating, which is polar form, we now say that this is what gave rise. So to find theta, this is the equation to use. This question said, find the equation for finding argument of a complex number. So the equation is simply theta equals to tan inverse of y over x. That is when it falls under the first or quadrant. But if we finish doing this and we notice that it falls inside the second quadrant, after getting the angle, we'll come and do 180 minus the angle. If it's here in the second, this is first quadrant, second quadrant. If it's in the third quadrant, you do 180 plus that particular angle. If it's in the fourth quadrant, you do 360 minus that angle. All right, so let's move to the last question. That is the last topic under this for this video. We'll still do a lot of things like properties and the rest, both ends and the Moverum's theorem. But for today's and this video, we're just stopping here. So they said, using the diagram below, explain everything on polar form of a complex number. All right, now first of all, all right, using the diagram below, explain everything on polar form of complex number. So this is the diagram. The y, the imaginary part, the x, the real part. So for us to explain polar form of a complex number, we need to understand that the polar form of a complex number is given by some sort of a guide. So for us to explain this now, it's simply going to be that, first of all, we need to know that in ARGAND diagram, the ARGAND diagram, this thing you're seeing here is an ARGAND diagram. So we say let O to M be equals to the x-axis, and then M to Q be equals to the y-axis. M to Q. Then O to Q, OQ will be equals to our R, and R is modulus. So what we do first is to find the modulus, and modulus R is equals to square root of x squared plus y squared. Once we find it, we now know that to find our theta, that is the argument theta, will be equals to tan inverse of y over x. Then once we get it, we also need to know that, just like I showed the other side, that r cos theta is equals to the x-axis and r sin theta is equals to y-axis. So if we know that for a complex number, and we say that our complex number, we are calling it z. Why the conjugate of a complex number, we call it z that is having a caret, or should I say a line on it. So z is equals to x plus yi. That is what polar form is talking about. That is, what complex number is talking about. So if that be the case, if we replace this x, it becomes that z is equals to r cos theta for x, then plus r sin theta for y-axis. So this is our normal complex number, but the polar form of a complex number is now us putting this into this form, which means that if simplifying this, we can also have this to be the same thing as saying bring out r, then just say cos theta plus sin theta. That is what it means. That's what it means. Now, remember, why are we doing this r? Remember that if we have this to be, that time that we did vectors, if we have this side to be, I'm rushing. If this side to be our r, notice that if we are taking this up, this line that we are taking up is r, is going towards the y-axis, it becomes r sin theta. If it's coming down, it becomes r cos theta. So that is why we have that the polar form of a complex number is given by r into cos theta plus sin theta. Now, and notice that since this part is having I, y is what is sin theta. So it's having I can put my I here. So that is why we now have it that in most textbooks you see it as I sin theta. That is to show you that this side is for the imaginary part. So that is for polar form of a complex number. So if I know this, then I said find the modulus and argument z and express z equals to 4 plus 3i in polar form. All right, let's try to see if we can do it. So we say modulus is r, argument is theta, polar form, and remember complex number is given. They gave us here 4 plus 3i. That means that the polar form will be the same thing as saying 4 cos theta plus I 4 sin theta. This is the polar form, because this is x, this is y, this is I. So theta, we don't know it, but we know that theta can be gotten by tan inverse of y over x. Then this one can be gotten by doing square root of x squared plus y squared. So using these equations, we can find these things that they've asked us to find. So what we can now do is to find the modulus. We say r equals to x here is 4 squared plus y here is 3. We don't put the I or when we are doing modulus, so use this. So this is going to simply give me 16 plus 9. Take the square. So this gives me root 25. So r is just 5. You see it, r is 5. Then for theta, that is the argument or anglement, I will just have tan inverse of y over that y here. Y in this case is 3 over x 4. So first of all, 3 divided by 4 is 0.75. So tan inverse theta equals to tan inverse of 0.75. So shift tan 0.75. So this gives me 36.87. So theta is equals to, so theta approximately 37 degrees. So if theta is approximately 37 degrees, first of all, I'm coming. So see, I know that yes, 1 pi is equals to 360 degrees, Shebi. So this can be the same thing as saying 37 degrees times 1 pi over 360 degrees. I'm coming. So if I do it, I'm going to have 37 divided by 360. So I have, this can be the same thing as saying 0.1027 pi. Okay, but we want to leave it in degrees, but I just did it in case they are asking you this. So yeah, sorry, what did I do? 2 pi, what are you saying? 2 pi is equals to 360 degrees. What are you saying? So yes, so this is going to be then times 2, so times 2. So this is supposed to be 0.2055 pi. Okay, but in order to confuse you, let's use the degree, but in case they ask you to convert it, so I now say, since it's in the first quadrant, theta is this, then they asked me to find the modulus. So to represent this, sorry, the polar form, to represent this in polar form is simply going to be just leave it, modulus. I did 4 cos theta. Why did you use 4 cos theta initially? This is not supposed to be 4 cos theta, because this is y and x. So rather, what I'm supposed to have is 5. That's why they normally tell you to hold on. So this is r. Remember, the in polar form is r cos theta. Then I sin theta. Should you remember I sin r theta? So this is supposed to be 5 for the model. So the polar form is going to simply be the same thing as saying, r into cos theta, that is into cos theta plus I sin theta. So this is going to be the same thing as saying modulus here is 5 into cos 37 degrees plus I sin 37 degrees. I can choose to do it. I can choose to find sine and cos. So if I find cos 37, it's going to be 0.7986. So plus I, that is, sorry, sine 37. So I have sine 37 is giving me 0.6018I. So multiply by 5. So this is the polar form of this. 0.786 plus 0.6018I. I can leave it like this. Now notice something. I'm leaving it because they are all in the same quadrant. That is the first quadrant. And remember that first quadrant is always positive. That is from yx positive. But here you have minus x. So this is going to be minus and positive x and y. Minus x and y. Y here is minus y. So here is minus x and minus y, negative. Here is minus and positive, so you have plus, that is for x, and then you have minus y. So please, thank you, subscribe, thank you.